Hello and good day. Here we are in pre-algebra covering our first objective of the year, classifying and identifying rational and irrational numbers. We are going to turn on the Smart Ink option. There we are. Okay, I think that's right. So yesterday we looked at some of the different icons that are going to be in these binder sheets. And we see the first two here. Defining a rational and an irrational number. Does anybody know the definition of a rational number? No. So we're all going to learn something new today. Excellent. Okay. So a rational number is a value, and how this works, you've got this exact same page in front of you. So you need to be writing down on your page everything that is put up here. Right? So you've got all the information. This is kind of like a guided notes thing. You're essentially writing your own information, your own math textbook that you can take with you further. So a rational number is a value that has a decimal that ends or repeats. A value with a decimal that ends or repeats is a rational number. A value with a decimal that either ends or repeats. So let's look at a number like 7. Is 7 rational? What's 7 written as a decimal?
7 over 1.
That would be a fraction, right? 7 over 1 would be a fraction. How about a decimal? 7.0. Does that decimal either end or repeat itself? Yeah, it ends, right? 7.0. It's the end. So 7 would be rational, right? How about 8.125? Is that rational? Is it a decimal that ends or repeats, Connor? Yes, what? Yes, it is, right? Because that decimal ends. 8.125, and that's it, right? Let's talk about fractions a little bit. You brought up a fraction. What about the fraction 3/4? Now, that's written as a fraction, but who knows what 3/4 is as a decimal? Yeah.
0.75.
0.75. Does that make 3/4 rational? Does that decimal end or repeat? Yeah, right? 0.75. Done. Ends. So you can have rational numbers that are just like 7, because as a decimal 7.0, that ends. You can have them in decimal form, like 8.125, that ends. Or you could have them in fraction form, because as a decimal 3/4, 0.75, that decimal ends. Who knows what the symbol is to show that a decimal is repeating itself? G?
You put a little line on top of it.
Exactly. So if we had something like 10.12 with that line over it like that, that means that the decimal is 10.121212121212121212121212, right? It repeats itself forever. That still fits into our definition of a rational number. That decimal repeats. Okay, therefore it would be rational. So most of the values that you deal with are going to be rational numbers. Okay, most of the values that you've grown up using in math are rational. So an irrational number would be a value with a decimal that does what? If a rational number has a decimal that ends or repeats, an irrational number, it kind of sounds like the opposite, like rational, irrational, would have a decimal that does what? G?
Not repeat.
Does not end and does not repeat, right? Exactly the opposite. So a value with a decimal that does not end or repeat. Essentially, that decimal goes on forever. An irrational number is a value with a decimal that does not end or repeat. Probably the most famous irrational number, the one that pretty much everybody's heard of, is pi, right? Pi, we use a symbol for because the actual decimal value, we don't know, okay? We have it calculated out to 2 billion places, but it doesn't end, and it hasn't shown any repetition. So we just use that symbol, or if you use it in the past, you probably rounded it to 3.114, right? I've got a poster here with the first, 100 or so digits of pi. Yeah. In fact, there's the math teacher joke that my bank PIN number is the last 4 digits of pi. But there aren't the last 4. We don't know what it's a math teacher joke, so it's dumb, but there you go. Okay. Does anyone know any other examples of irrational numbers? What's the symbol, the mathematical symbol for a decimal that does not end or repeat? I mean, we can obviously see if the decimal ends because it stops, like 8.125 stops. If it does repeat, it's got that bar over it. What's the math symbol for it not repeating? Anybody know? A decimal like 4.3265, and just continues on and on and on. We use the dot, dot, dot. Right? Kind of like in a text message when your parents ask how your school day was, and you say, fine, dot, dot, dot. Right? It means like, well, there's more. Okay? This is the mathematical symbol for the decimal not ending and not repeating. It just continues on. Okay? Questions, comments, concerns, compliments, criticisms, congratulations so far. Connor? Okay. All right. This key point here says the square root of a non-perfect square will always be irrational. We'll talk about square roots in a future objective. I believe it's number 12. But an example of a perfect square, and this comes up in my danger warning here too. The root of 25, what is the root of 25? Ifan? 5. So the root of 25, is that rational or irrational? Since the value of the root of 25 is 5, does that make the root of 25 rational or irrational? Rational, right? Because 5.0, it ends. Okay? If we're taking something like the root of 12, 12 is considered a non-perfect square because there's no integer that when you multiply it times itself, or no number that when you multiply it times itself, it equals 12. If you were to type the root of 12 in a calculator, you get something like 3.4 blah, 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 blah. Decimal goes on forever. So whereas root 25 is a perfect square because the square root of 25 is 5, right? Or the root of 49 is 7. It works out evenly. The root of 12 doesn't. Like I said, it's like 3.4. I'm just making this up. 4, 2, 3, something, dot, dot, dot. Okay? So if you ever have the root of a non-perfect square, it is always going to be irrational because the roots of non-perfect squares, those decimals go on forever. Okay? So when you're looking at these values in your homework, be very careful. The root of 121 looks complicated, but what is the root of 121? Anybody know? What number times itself equals 121? It is 11. So root of 121, even though it looks complicated, might look like it's irrational, it's actually rational because its value, 11.0, is a decimal that ends. Okay? To check your answer, explaining why a value is rational or irrational helps defend it. Does the decimal end? Yes, rational. Does the decimal repeat? Yes, rational. Does the decimal go on forever? Yes, irrational, right? So if you kind of think through it and just kind of defend it a little bit, that's one way you can check your answer. So your assignment for tomorrow, and we're going to clear the ink here, is to put the pen down. Here we go. Label each number as rational or irrational. Check your answer by explaining why. Pick one from the top row that you'd like to do together. Which one? Pi. Okay. Pi, is it irrational or rational? Irrational, right? And why? Well, because we know the decimal is 3.14, look at my poster, 15926, and it goes on. Okay? The decimal does not end, it does not repeat. That's a definition of an irrational number. So that's what I'm looking for here. Yes?
Can you just write an R or an I for rational or rational?
I like your style. The question was, can we just write an R for rational or an I for irrational? I always say that math people are some of the laziest people out there because we're always trying to find the quickest way to get to an answer. You know, what's the most efficient way to solve it? Yes, if you want to write R for rational, I would prefer IR for rational just because I will use that for integer later on. So if you can manage to put the extra R after the I, that'd be helpful. Okay. How about one from the second row? What would you like to do? Which one would you like to do from the second row, Samara? The root of 196. Ooh. Is that a perfect square? Is there a number that when you multiply it times itself gives you 196 or not? We already said that 11 times 11 is 121. What's 12 times 12? What? 144. What's 13 times 13? You might remember this because it's a highway that many of you probably take to get here in the morning.
Oh.
G?
169.
169. So we're getting closer. What's 14 times 14?
What class am I in?
This is pre-algebra.
Okay, am I in this class?
Carolyn?
Yeah.
Yes, you are.
Okay.
You can have a seat up here next to me for right now. Oh yeah, what's 14 times 14? Yeah. 196, we hit it. So the value of the root of 196 is 14. Does that make it rational or irrational? Rational, because that decimal ends. Okay. So when I check your homework tomorrow, and it's not something that you're turning in for me to correct for right and wrong answers, I want to walk around, make sure you've got everything finished. It looks, like you didn't just quickly write a bunch of words in, right? I can pretty much tell. This is what I want to see. I want to see your answer. Is it rational? Is it irrational? And then some defense of why. So if all you have is the word written down, that's not enough. You got to tell me why. Connor, you have a question? You're right. Today's Friday. Monday. Thank you. Yes. You will get to use calculators on certain concepts. Not too many in this first unit, though, just because this is kind of like that number sense unit. But as we get into more complicated things, yes, calculators will be allowed. Okay. The second section here. It says, let's focus on square roots, also called radicals, for just a bit. If I asked you for an irrational number between 2 and 3, so I'm looking for an irrational number between 2 and 3. So we're looking for a decimal that does not end, does not repeat, that's between the values of 2 and 3. Why would any of these four roots, root 5, root 6, root 7, or root 8, each be an acceptable answer? If I'm looking for an irrational number, somewhere between the values of 2 and 3, and I'm telling you that root 5, root 6, root 7, and root 8 are all acceptable answers. Why is that? Well, what square root has a value of 2? The square root of what number equals 2?
6 and 8.
Nope, the square root of 6 isn't 2. The square root of 4 isn't 8. Yeah?
2.
The square root of 2 is not 2. Remember what roots mean, right? If up here, the reason why the root of 196 equals 14 is because 14 times itself is 196. There's one above. We did the root of 25. The reason why the root of 25 is 5 is because 5 times 5 is 25. So what number is going to equal, or the root of what number will equal 2?
1.
No. Go the other way. Yeah?
4.
Lucas, root of 4, right? The square root of 4 has a value of 2 because 2 times 2 equals 4. The root of what number will equal 3? 9. The square root of 9 equals 3 because 3 times 3 equals 9. So if we're looking at a number line here, and we know that the root of 4 is 2, the root of 9 equals 3, that means that 5, 6, 7, and 8, the root of 5, root of 6, root of 7, root of 8, are all going to be somewhere in between here, right? Because root 4 is 2, so root 5 is going to be a little bit more, between 2 and 3. Root 6, a little more. Root 7, a little more. Root 8 is almost 3, because the root of 9 is 3. See how I reasoned through that there? Okay? Let's talk about one here. Oh, I keep forgetting I'd set the pen down before I scroll. Oh boy. Oh boy. There we go. Okay. So, written as a root, what is an irrational number between 5 and 6? So just like I did up there, I'm going to make a little bit of a number line here. Here's 5. Here's 6. I'm looking for an irrational number, so the root of a non-perfect square, that's going to have a value between 5 and 6. So we already talked about that the root of 25 is equal to 5, because 5 times 5 equals 25. What is the value of 6 using a root? The square root of what number equals 6? 36. Okay. So if the root of 25 is 5 and the root of 36 is 6, what is a root that's going to have a value between 5 and 6? Anyone care to take a chance? Yeah?
5 and a half.
Sorry? You said 5 and a half?
Yeah.
Well, so that is a value that's between 5 and 6. So if we want to go halfway between 5 and 6 and get a value of 5.5, the root of that is going to be about halfway between root 25 and root 36. So it's going to be about, we'll say, root 30. Okay? But because 30 is a non-perfect square, that's going to be an irrational number. It's not going to equal 5.5 exactly, right? Because we already said that the root of a non-perfect square is an irrational number. That decimal goes on forever. So root 30 would be an acceptable answer because it is between root 25, which is 5, and root 36, which is 6. Give me another answer that would be correct. The root of a number that would be between 5 and 6.
29.
Root of 29, sure, right? Because that's between root 25 and root 36. So its value will be between 5 and 6. Give me another possible answer. How about root 28? Yeah? Root 27? Yeah? Root 26? Root 31? Root 32? Root 33? Root 34? Root 35? The root of any number between 25 and 36 will have a value in between 5 and 6. So root 40, would that one work? No, because root 40 would be over here, right? That's greater than 6. Okay? It is an irrational number, but it's not between 5 and 6. So that's kind of that bottom section there. The next one, written as a root, what is an irrational number between 9 and 10? So kind of the same setup here, right? You've got the numbers 9 and 10. What are each of those numbers as roots? And then what is a non-perfect square that would fall between them? And then written as a root, what is a rational number between root 130 and root 150? Root 130 and root 150 are both irrational. They're non-perfect squares. I'm looking for a rational number. What is a perfect square between root 130 and root 150? Okay? So that is your homework for Monday. Complete the page here. That is how you math.
Don't forget to like and subscribe.
That wasn't horrible.